Hey, what's up, guys? This is Guy here with KB Trainings, where I share with you my passion in networking, among many other things. And today I was just sitting doing some labs, and I'm like, yeah, let me shoot this. This is going to be our lab number 2 for the Cisco ENCOR for 350-401. In the lab number 1, I built this topology for you. So we have a topology here with 2 switches, 3 VLANs, and 3 PCs per switch, and 1 PC per VLAN on each switch. So right now PC1 is in the VLAN 1 along with PC4. PC2 is in VLAN 20 along with PC5, and PC3 is in the VLAN 30 along with the PC6. So today we're going to focus specifically on the point number 3.1.A, which asks us to troubleshoot static and dynamic 802.1q trunking protocols. So this is the topology that we have. The trunk is working right now. We can verify it in the switch by doing show interface trunk. We can see that we have a trunk on the port 0/0. This trunk supports all these VLANs from 1 to 4094, and it's also passing traffic for VLAN 1, 20, and 30. And also we can take a look at our ports to make sure all the ports are in the right VLAN. We can do show interface status. That will show us all the details we need to know about our ports. We can see that the port 0/0 is a trunk, of course, that's what we want. The port 2/0 is in the VLAN 20, it's connected, and the port 3/0 is in the VLAN 30, and that is on both switches. This is switch 2. We have the same situation, so everything is working now fine. Everything is working perfectly. So before we go deeper, let's say a quick word on VLAN trunking and DTP. So you need to know that trunking is universal. Specifically 802.1q is IEEE standard, so it's universal. All the vendors can implement it on their devices, but dynamic trunking protocol is Cisco proprietary. So if you are connected to a different device that is not Cisco, you need to know that that device may not be able to form a trunk with you if you are talking DTP. If you are sending DTP frames, the other device will not be able to understand. But if you are both using 802.1q, you need to force your device to trunk. So you need to use the command switch port mode trunk. That will start sending, that will make your device, your interface a trunk, and you'll be able to talk to the other device. So you need to know that. And trunking is also called tagging by other vendors. So it's not always going to be trunking. It will be tagging for other vendors. And these are different combinations that you can do and different results that you can get depending on what you have on each side of your link. So what I want to talk a little bit is this combination. So if you have access on one end and you have trunk on the other end, in that case you will have limited connectivity. What does this mean? Depending on your configuration, you can still pass traffic for a single VLAN, and that VLAN is the access VLAN on one end, and it needs to be the native VLAN on the other end. So if you don't have that, you will not be able to pass traffic. We can test that. Let's test what's going on. So I showed you that we have our devices here running the ping, so we can see exactly what's going on if we are tweaking stuff. And that's what you should be doing when you're doing your labs. You should ask yourself a lot of what if questions. That's how you learn. That's how you know what happens in different circumstances. You need to ask yourself, what if this is that? What happens? What if that is this? What happens? So that will just help you master a lot of things. So what we want to do is change the interface gig 0/0 to an access port and see what happens. So we're going to do configuration interface 0/0. We're going to do switch port mode access. We know it's VLAN 1 already because we can check it by doing show show interface gig 0/0 switch port. Oops. Show interface 0/0 switch port. It's now a static access and it's in the VLAN 1. So right now what should happen on our topology? I can predict, and I know that in this instance only VLAN 1 will be able to get across. All the other VLANs, VLAN 2 and VLAN 30, I mean VLAN 20 and VLAN 30 will be cut off from that link. Let's verify that. So if I come here on PC1, it's the only one pinging. And why did we have this downtime? This is STP, spanning tree protocol. When I changed the state of the port gig 0/0, spanning tree protocol, the spanning tree protocol instance needed to be restarted. So that's why it was cut off. It went through the learning and everything before start forwarding. So if I go in PC2, of course there's no link because the port is accessed. VLAN 20 is not going through, and VLAN 30 is not going through either. So this is how we can verify this. And yeah, this is one of the symptoms. If one of the VLAN is going through, make sure you are trunking on both ends. And if I also do show interface trunk, you can see that we don't have any trunk. It's empty. There's no trunk at this moment. One other thing we can do to verify is to change that to change the interface to be a switch port access VLAN 20. This will only allow VLAN 20 to go across. And if you go back to our devices, you can see that VLAN 1 is shut down. VLAN 20 will start really soon. So just after spanning tree has done its things, we can check spanning tree by doing show spanning tree VLAN 20. You can see that right now it's learning, and we can refresh again. Right now it's still learning. Now it's still learning. Now it's forwarding. It's forwarding, but we have a problem. We have an issue. I think some of you saw the thing that we have here, so the message that we have. But if we go under PC2, we can see that VLAN 20 is still not going across. Why is that? VLAN 1 is not going, VLAN 20 is not going, VLAN 30 is not going. Why is that? Because we put this port in the VLAN 20, and VLAN 20 is not a native VLAN on switch 2. Switch 2 is expecting VLAN 20 to have a tag on it. So if we want VLAN 20 to work, we need to make sure that the native VLAN for that port on switch 2 is set to VLAN 20. In the working environment or production environment, that's not supposed to happen, because you just need to build the trunk. If you need the trunk, you can be building access on one end and having the trunk and trying to tweak with the native VLAN. But we're just doing it for our lab so we can just practice. So if we go under the interface gig 0/0 and we do switch port trunk native VLAN 20, of course we can do show spanning tree VLAN 20. It's forwarding already. Okay. And if we go on the PC1, there's no traffic, but PC2 will be sending traffic really soon. Let's give it a moment. We can verify that by coming here and do show interface trunk. Oh, there's no trunk. Oh no, I'm not supposed to use the trunk thing. I need to use the switch port access VLAN 20. Yep, that's what I'm supposed to use. And PC2 should be starting pretty soon. Let's check spanning tree. So it's listening. Port 0 is listening. It's now learning. And if you don't want to wait for 30 seconds, you need to activate port fast. I mean, if you are sure your port is an access port. It's still learning. Now it's forwarding. So if you go back to VLAN 2, I mean VLAN 20 is passing traffic. So that's how it is. Let's return to normal by doing conft 0/0 switch ports modes dynamic. Let's set it to desirable. And let me see, do show oh yeah, I see. So do show interface gig 0/0 switch port. Okay, desirable. It's running as a trunk. The native VLAN is VLAN 20. We don't want that. Let's set VLAN 1 as the native VLAN. Switch port trunk native VLAN 1. Let's redo that command. So we can see that it's now trunking. Native VLAN is 1. Oh, I don't know. First time I looked here, I'm not sure. Native VLAN is 1. But if it's doing access mode will be on VLAN 20. We can change that as well, just to make sure that if we ever go access, it will still be a VLAN 1. I don't think we have to. But let's go on VLAN 2. Let's see if we have any trunk now. Do show interface trunk. Yeah, now we have a trunk. And I think all the three... No, PC1 is still not passing traffic. Why? Oh, only VLAN 30 is passing traffic across. Okay, that's good. I like that. So we need to figure it out. What did we mess up and what can't we catch here? So let's go back in switch 2. What message do we have? VLAN mismatch. Not a VLAN mismatch. Let's see. Do show interface gig 0/0 switch port. We can see that it's trunking and the native VLAN is 20. Okay, let's change that. So we need to do switch ports trunk native VLAN 1, and that will change, I think, spanning tree a little bit. Let's check spanning tree. Oh no, we should be checking for VLAN 1. Okay, we can see that port 1 is blocking for now. Oh, PVID inconsistence. Okay, yeah, it's been restored. Okay, let me see that message. I didn't get it. We received that alert somewhere here. Okay, it says received PVID error, received BPD with inconsistent peer VLAN ID 20 on gigabit 0/0 VLAN 1. Okay, so the port was blocked for that reason, and apparently it's been restored. Let's look at spanning tree again. We can see that the port is forwarding. So if we go back, PC1 is sending traffic, PC2 is sending traffic, PC3 is sending traffic, which is great. So we returned to our previous state. We fixed everything. And I have some notes here. Let me go back to my notes. All right, so I want to mention that before doing all of this, when you are troubleshooting, you need to make sure you have a link between the two switches. How do you know you have a link? You need to check your the status of your interfaces. If you do show interface status, it can show you what port is in what VLAN, what port is a trunk, and you can have an idea on everything. And also what port has something connected to it. That's how you know. Or one other way would be to check your CDP neighbors. We see that we are connected to switch 2, which is great. So we need to make sure we have a link before doing anything. That's layer 1 troubleshooting. We always have to do it. And the second thing, I wanted to talk about native VLAN mismatch, which I just did. So you need to make sure the native VLAN are the same on both sides, because native VLAN do not have tags on them. So you need to make sure it's the same. Third thing, you need to make sure that DTP is present and is activated. What do I mean by present? Does your device support DTP? As I told you, some devices don't. I mean, all the Cisco devices should support DTP, but if you have a device that's not a Cisco, you need to make sure that you don't use DTP, because it will not work. Other devices do not talk DTP, like other vendors do not talk DTP. And also you need to make sure DTP is activated. What do I mean? DTP can be activated or deactivated on a port or an interface. By activation, you can use one of these modes. If you set it to dynamic auto, dynamic desirable, that means DTP is activated. Dynamic auto doesn't negotiate, it just wait. I mean, it's negotiating, but it doesn't initiate the negotiation. It's waiting for the neighbor to do it. Dynamic desirable will start the negotiation and move on with it. So if you want to disable DTP, you can do it by setting the port on access if you don't want any trunk, or you can force the port to be a trunk. So whatever you have on the other end, you'll still be fine. You can either form a trunk or not form a trunk at all, but also make sure your native VLAN is configured properly, so that at least one VLAN can get across. Okay, all right, so I wanted to talk about DTP mode mismatch. This is just things like if you have auto, you won't have any trunk formed on it. If you have auto and access, you won't have any trunk, of course. So if you have trunk and access, you will have limited connectivity. I talked about it already. So these are some commands that you need to know. You can debug DTP packets. It will show you different activity, the different packets that are being sent by your interfaces. So we can do debug DTP packet. Here we're going to see a bunch of messages appearing really soon. And it's going to show us packets from all the interfaces. Alright, you can see this is 0/0, sending and receiving. Let's wait for some other ports. Yep, 3/3, 3/2, 3/1, 3/0, 2/3. So all the interfaces, we can see what they are sending, because even though they are under dynamic auto, they are still sending DTP frames. Let's stop the debug. So we can see here, like for example, the port to 3/3 sending a packet. It's just informing the other side. My trunk operational state is access, but my trunk administrative state is auto. So right now I'm running as an access port, but I can build a trunk for you if you are if you desire to build a trunk, or if you are a trunk, we're going to be a trunk. My trunking operational type is ISL. My trunking administrative type is negotiate. So I can negotiate, but I prefer ISL, which is not covered by the certification. So that's how you read the different packets that are being sent. Yeah, what else? So we talked about DTP mode mismatch and the different commands. You show me using these commands: show interface gig /0/0 switch port, show interface status, show interface trunk, show DTP. You can do show DTP as well. This will show you that the packet is sent every 30 seconds. The timeout is 300 seconds, and you have 16 interfaces that are using DTP on this device. You can also see the running configuration on an interface by doing show interface. I don't know, show running config on an interface gig 0/0. These are the commands that we have under this interface. Okay, it's still under access VLAN 20. Yeah, it doesn't matter anymore because it's under desirable. It's trunking anyway. And the native VLAN is not showing here. I wonder. Show interface 0/0 switch port. Okay, we sent a command for the native VLAN to be 1, but we don't see it under the running configuration. Interesting. Negotiation. Yep, that's what it is. So it's working now. Our PC 1, 2, and 3 are working, which is a good thing. And if you have any problem, you will see an alert or a message sent to you. And if you don't have any problem, just do some pings. If you have any problem, do the pings, check the status of the trunk, check the status of the port, and know how to read all these results. Know how to read the result from your switch. Like if I do a short interface trunk, you need to know how to read all of this. Oh, also I want to talk about something, how you can allow or block some VLANs from going across. So let's say VLAN 20 is here. Let's block the VLAN 20 from crossing the trunk. So we are going to go under the interface 0/0 and do switch port trunk allow allow VLAN accepts 20. If we do that, boom, this one is out because we are blocking VLAN 20 from crossing the trunk. So because I told you we're going to use this topology for our future labs, so let me just go ahead and forgive the VLAN 20 and return it to normal. Does he have to wait for spanning tree? I think so, yeah. Let's see. It should be coming up pretty soon. All right. Yep, after the 30 seconds, we have our PC2 patching traffic. There's one more show command that you can run to get some more information on the DTP on a certain interface. It's show DTP interface, whatever interface you're using, gigabit 0/0. This will give you a lot of information on dynamic trunking protocol on a certain interface. Like in this case, we are looking at 0/0, which is the trunk connected to 0/0 on switch 1. So you can see this is trunk operational status, trunk administrative status, and trunk negotiation status. We can see that operation status is trunk, administrative is auto, so it's dynamic auto, and negotiation is trunk. So for now it's negotiated to be a trunk. And this is trunking operational type. We have 8021Q. Trunking administrative type, we have negotiate, and trunk negotiation type, it's 8021Q. So we have a bunch of information. This is the switch that we have on the other end. This is the hello timer expiration. We can see that if we refresh the page, this is 27, so it just sent a hello timer, or received the hello timer, I think. Yeah, so we also have all kind of detail. FSM state, the trunk is STP enabled. Yes, you can see it here. And yeah, we have 13 packets sent and so on. Let's look at another port that is access, an access port, and see if there's any change. Even though it's an access port, DTP is still enabled because it's set to dynamic auto. So if we go under that port and set it to access, switch port mode access, you can see that if we do the same command, DTP is disabled. So now it's disabled. All right, that's all for today, guys. I hope you enjoyed it. It was just as simple as that, but of course, take your time to play with it. If you do not master where is what, if you don't know where you can find things to troubleshoot, do it, because you don't want to be stressed in a work environment. Some people are. You are stressed because you're not sure what you're doing, but doing a lot of labs will help you master, will help you know exactly what you're doing, and you're just going to be a happy man. Do a lot of labs, and I'll see you in the lab number 3. I don't know what I'm going to cover, but it's going to be something awesome as always. If you want to check out my course on the CCNA 200-301, go ahead and go on kbtrainings.com/CCNA. You'll find it there, and you learn all of this, because at the ENCOR level you're supposed to troubleshoot and do other things. At the CCNA level you're just supposed to configure. So thank you so much for your time, and I'll see you in the next video. Bye.